Welcome to Sankalp Learning Classes. In this session, we'll be discussing 2 mark questions of the chapter Determinants. Already we have discussed the 1 mark question, so we'll straight away go to the questions of 2 marks. All right. So the first question is, find the equation of the line joining. Find the equation of the line joining the points of the line joining the points joining the points 3, 1 and 9, 3 using determinants. Okay, so they have asked to find out the equation of line. Which line? They have given 2 points, 3, 1 and 9, 3 are the 2 points of that particular line. You have to find out the equation of that line. Okay, you have to represent that line in form of x and y, right? So how will you do that? They have asked you to do it using determinants. Okay, so you have studied the application of determinants. That is, you know how to find out the area of a triangle, right? And you know how to check the consistency of a system of linear equations, right? So by using the area of triangle, the formula that is used to find out the method that is used to find out the area of a triangle, you can find out the equation of a line also. How will you do that? How will you do that? You know, the area of a triangle is found out using determinants by if x1, y1, x2, y2, x3, y3 are the 3 vertices of a triangle, then we can find the area of that particular triangle using determinants. How will you do that? You have to arrange the vertices in this manner, right? x1, y1, x2, y2, then x3, y3, and the last column should all be 3. Sorry, 1. All be 1. The last column, all the members are 1. All right. And on solving this particular thing, you'll get the area of that particular triangle with the vertices x1, y1, x2, y2, and x3, y3. Right? Okay, now what happens to the points that are on a line? Okay, if the 3 points of this triangle, if the 3 points given are on a line, okay, that is x1, y1 is here. Okay, this one is x2, y2. Okay, this one is x3, y3. So can you form a triangle using these 3 vertices? Having these 3 vertices, can you form a triangle? No, because all the points are on a line or on the same line, collinear points, right? We say the points that exist on the same line as collinear points, right? So these are collinear points. So we cannot form a triangle, right? We cannot form a triangle using these 3 vertices, right? So what will be the area of the triangle? A triangle itself cannot be formed. So what is the area? Area will be 0. So area of a triangle with 3 points lying on the same line, which means if the points are on the same line or if the points are collinear, then we can say that the area is 0. So if the so this will become 0, right? Area of the triangle will become 0, which implies if you take this 1 by 2 to that side, 0 into 1 by 2 is 0, right? So you can say that the value of this determinant will be 0 if the points are lying on the same line. If the points are collinear, we can say that this determinant will be equal to 0. That will be equal to 0. Now, with the help of that idea, we can find out the equation of this line, having 2 points as 3, 1 and 9, 3. Now you suppose that the third point as x and y. Okay, that is, consider the line. So they have given one point is 3, 1, other point is 9, 3, and now you suppose that this point be xy. Okay, and then you substitute in this one and you equate it to 0, then you will get the equation of the line joining the points. All right, so I'm going to do that. First of all, we need to arrange this as determinant, right? So the first vertices, I'm going to write it as 3, 1. So the second point is 9, 3, and the third point is xy. Okay, xy is a general point on that line. All right, we need an equation of that line, right? So that's why the third one, you just put it as x and y. All right. And the third column, all the members are 1. Okay, this is equal to 0 because all the 3 points lie on the same line or they are collinear. So the determinant value will be equal to 0. All right. Now you know how to find out the determinant of a 3 by 3 matrix, right? You know how to find out the determinant of a 3 by 3 matrix. You have to expand it along any row or any column. So here I am choosing the first row itself. Okay, you can choose the third row or you can choose the second row or the first column. Anything else you can choose. Here I am choosing the first row itself. Okay. Anyway, you will get the same value because one matrix have only one determinant. So in any way, if you take any row or any column, you'll get the same value. You should get the same value, right? So here I'm taking the first row. So 3 into 3 minus y, right? 3 minus y. Then you have to put a minus there because 1 is in A12 position. So 1 plus 2 is 3. It is an odd number. So you have to put a minus there. Now what happens? You have to eliminate the row and column containing 1. Okay, so this is the row and column containing 1. So what is remaining? 9, 1, x 1. You have to cross multiply. 9 into 1 is 9 minus x into 1. X into 1 is x minus x, right? All right, minus x. Then plus 1 into, you have to remove the row and column containing, so here, this is the column and this is the row containing this one, right? So what is remaining? 9, 3xy. You have to cross multiply. 9 into y is 9y minus x into 3 is 3x, right? So this will become 9y minus 3x, that is equal to 0. Okay, so 3 into 3, then 3 into minus y. 3 into 3 is 9, minus 3 into y is minus 3y. Then minus 1 into 9 is minus 9, minus 1 into minus x is plus x, right? Plus x plus 9y. Then 1 into minus 3x is minus 3x, that is equal to 0. Okay, now 9 minus 9 is 0. And what is remaining here? 3y minus 3y plus 9y. Minus 3y plus 9y can be written as 6y, right? So I am going to write it here, okay? So 9y minus 3y is equal to 6y. And what else are remaining? X minus 3x. X minus 3x can be written as minus 2x, right? Minus 2x equal to 0. So you can take 3 outside from this. Sorry. You can take 2 outside from this, right? So 2 into 3y minus x equal to 0. So if I take this 2 to the other side, this will become 2 into 0, that is 0, right? So 3y minus x equal to 0. Or else you can write it as minus x plus 3y equal to 0. And on multiplying throughout by minus, that is, you can rearrange this minus x plus 3y equal to 0. You can write 3y minus x equal to 0 as minus x plus 3y equal to 0. And if you multiply throughout by a minus, okay, multiply throughout by a minus or minus 1, you will get x minus 3y equal to 0. So what is the equation of this particular line? X minus 3y equal to 0 or x equal to 3y. Okay. So moving on to our next question. Find the area of the triangle whose vertices are 3, 8, minus 4, comma 2 and 5, 1 using determinants. All right, you have to find out the area of the given triangle. Okay, given triangle means they have given the vertices of that triangle. What are the vertices? One vertex is 3, 8, another is minus 4, 2, and the third one is 5, 1. You have to find out the area of the triangle. We know how to find out the area of triangle using determinant, right? So what is the formula? Half of x1, y1, 1, x2, y2, 1, x3, y3, 1, right? And what is this x1, y1, x2, y2, etc.? These are all vertices of the triangle, right? So this is how you find out the area of a triangle, area of triangle. All right. So this can be written as area is equal to half of 381 minus 421, then 511. So this is our area. All right. And now what you have to do, you have to find out the determinant. So you put half there itself and find out the value of the determinant first. Okay. So this is a 3 by 3, 3 by 3 matrix, right? So you have to expand it along any row or column. So I am expanding it along the first row. So the first thing is you have to eliminate the row and column, right? This is a column and this is a row and column containing 3. So what is remaining? 2, 1, 1, 1. This is the minor, right? So what is the minor of determinant of that particular minor? That is equal to, you have to cross multiply, right? 2 minus 1. 2 into 1 is 2 and 1 into 1 is 1. So it is 2 minus 1. Then you put a minus there and then what is the value? 8. 8 into, you have to remove the column and the row containing 8. Column and row containing 8. So what is remaining? Minus 4, 1, 5, 1. Right? Minus 4, 1 and 5, 1. So what is the value? Minus 4 into 1 is minus 4. Minus 5 into 1 is minus 5. Right? Then plus 1 into what is remaining? Minus 4 to 5, 1. So minus 4 into 1 is minus 4. Minus 5 into 2 is 10. So what is the value? Minus 4 minus 10. 5 into 10 is 10. Okay. So what is the value here? We can solve it here itself. Okay. So that is half of 3 into 2 minus 1. 2 minus 1 is 1. So 3 into 1 is 3. So 3 minus 8 into minus 4 minus 5, that is 8 into minus 9, right? Then plus 1 into minus 4 minus 10, that is minus 40. Okay, so this is a value. So how will you find it? I'm going to write the remaining here. Okay, so that is equal to half of 3 minus 8 into minus 9. 8 nines are 72. So plus 72, right? Plus 72 and minus 40. Minus 40. So half of 72 plus 3 is 75. 75 minus 14. 75 minus 4 is 71 and minus 10 is 61, right? So 61 into 61, which means 61 by 2 square units. What is the answer? 61 by 2 square units. Okay, so what is the area of the given triangle? It is nothing but 61 by 2 square units. All right, now we are moving on to the next question. The third question, if the area of the triangle with vertices, if the area of the triangle with vertices minus 2 comma 0, 0 comma 4 and 0 comma k is 4 square units. It is 4 square units. Find the value of k. Find the value of k using determinants. Find the value of k using determinants. Okay, so they have given the area of the triangle. Area of the triangle is nothing but 4, right? So here you can see this is the area of the triangle. It is 4 square units and the 3 vertices. 2 of the vertices they have given the value. In the third vertex you can see that the y coordinate is missing. It is 0k and you have to find out that missing coordinate. Find the value of k using determinants. Okay, you have to find out the value of k, that is using determinants. Okay, so how will you do that? You know, area of a triangle is equal to half of x1 y1 1, x2 y2 1, x3 y3 1. Okay, so here what will happen? Half of, I'm going to substitute the vertices. So the first one is minus 2 0 1, then 0 4 1 and 0. The next one is missing, so put it as k itself, 0 k 1. that is equal to plus or minus 4. So whenever you are given the area of a triangle, you have to consider its negative value also. Okay, on solving the determinants, you have to put the negative value also. So you should consider plus or minus 4. All right, now what I'm going to do is that I can take this 1 by 2 to the other side, right? So the determinant will be minus 2, 0, 1, 0, 4, 1, 0, k, 1. That is equal to plus or minus 8 because 4 into 2 will become 8, right? So this is the value is plus or minus 8. Now you can solve this, right? So, so it is a 3 by 3 determinant. So I am expanding it along the first row. So this will be minus 2 into minus 2 into. So this is I'm considering. Okay. So what is remaining here? If I remove the row and column containing minus 2, what is remaining? 4 into 1 is 4. Minus 1 into k is k. Right. Then you have to put a minus there. It is 0. 0 into anything is 0. So you don't need to write actually. But since you are studying, we can write that step also. That is minus 0 into. If I remove this column and row containing 0, what is remaining? 0 into 1. That is 0. Minus 0 into 1 is 0. Alright. Now, what happens when the third element is 1? So you have to remove the row and column and row containing 1. So what is remaining? 0 into k minus 0 into 4. So that is actually 0. Okay. So here you get this is equal to plus or minus 8. Only this values, all the remaining exist. All the remaining values become 0, right? 1 into 0 is 0. 0 into 0 is also 0. So if you expand this, what will happen? Minus 2 into 4, minus 8. Then minus 2 into minus k is plus 2k. That is equal to plus or minus 8. So two values will exist, right? So minus 8 plus 2k can be 8, right? Or minus 8 plus 2k can be minus 8. It can be minus 8, right? So 2k will be 8. If I take this minus 8 to the other side, it become 8 plus 8. So 2k can be 16, which means k can be 16 by 2. That is equal to 8. So we have got one value. The other value is 2k is equal to minus 8 plus 8. Right? Minus 8 plus 8. So 2k equal to 0. So k equal to 0. So what are the possible values of k? K can be 0 or k can be 8. Okay. K can be, it can be 0 or it can be 8. Alright. Now moving on to our next question. So this is our fourth question. Examine the consistency. Examine the consistency of the system of equations x plus 3y equal to 5 and 2x plus 6y equal to 8. So these are the system of equation x plus 3y equal to 5 and 2x plus 6y equal to 8. Okay, so here how will you check the consistency? You have to write the matrix A and B, right? So how will you write the matrix A? A is equal to the coefficients of x and y, right? So the coefficient of x is 1 and coefficient of y is 3. So the first row will be 1, 3. And what is the second equation here? There are only two equations, so it will be a 2 by 2 matrix, right? So here you can see that it is the coefficient of x is 2 and the coefficient of y is 6. So the second row will be 2, 6. So this is our matrix A. Okay, now what about matrix B? Matrix B is the right side values. What are they? 5 and 8. 5 and 8 are the matrix B. Okay, now what is X? X is the unknown matrix. Unknown values are X and Y. So this is how you transform a system of linear equations into matrix form. And we know this is actually like Ax equal, the system of linear equations are actually like Ax equal to B. And you know how to check the consistency. There are three rules, three rules. What are they? The first one is if determinant of A is not equal to 0, then we can say that the system is consistent and it has unique solution, right? It is not equal, when determinant is not equal to 0, it is consistent and it has a unique solution. We are actually dealing with that type of equations only in order to solve. Okay, we will be only giving to solve the system of linear equations that are consistent. Okay, but you will be given system of linear equations that may be inconsistent and that has no solution, because you have studied the rules for that. What were they? The second rule was, if determinant of A equal to 0 and the product adjoint of A into B is not equal to 0, then we can say that the system of linear equation has no solution. That was the second rule, right? And what about the third rule? If determinant A equal to 0 and adjoint of A into B, the matrix multiplication adjoint of A into B, that is also equal to 0, then we can say that the system can be consistent. Okay, it may be consistent and it has infinitely many solution. Okay, it will be having infinitely many solution. Okay, so these were the three conditions for a system to be consistent. Okay, so what can we say? Determinant A is not equal to 0, then definitely it is consistent and it has only one solution. It is a unique solution. And if determinant A is equal to 0, then there are two possibility. Either it has no solution or it can have infinitely many solution. When it can have no solution, if the adjoint of A into B is not equal to 0. When will it have infinitely many solution? If adjoint of A into B is equal to 0. All right. So that is a rule that you have to consider here. So here, first you have to check determinant A. That is the first thing, right? You have to check whether determinant A is equal to 0 or not equal to 0. So determinant A is equal to, it is easy since it is a 2 by 2 matrix, right? So 6 minus 6, 2 into 3 is also 6, right? 6 minus 6, that is equal to 0. So determinant A is equal to 0. So there are two possibilities. Either this system has no solution or it can have infinitely many solution. For that, what you have to consider? You have to consider the product adjoint of A into B, right? Adjoint of A into B. And what is adjoint of A? Since this is a 2 by 2 matrix, we can write the adjoint easily, right? How will you do that? You have to interchange the diagonal element. You have to interchange the diagonal element and you have to change the sign of the non-diagonal element, right? Which are the non-diagonal elements here? 3 and 2. So you have to change the sign of 3 and 2. So this will become minus 3 and this will become minus 2. So this is our adjoint matrix. This is our adjoint matrix. And what about B? What about B? That is equal to, 5 8. B is equal to 5 8. Okay. I'm sorry, you can write this as another step. So this is our adj, and now we need to find out the product adjoint of A into B. Okay, so we have to find out adjoint of A into B. So that is equal to 6 minus 3 minus 2 1 into 5 8 into 5 8. All right. So how will you do that? Okay, so 6 into 5. 6 into 5 is 30. Okay, minus 3 into 8. Minus 3 into 8 is minus 24. So this is our first element. And now you multiply the second row with the column. So minus 2 into 5 is minus 10. Plus 1 into 8 is plus 8. So that is equal to 30 minus 24. That is 6. And minus 10 plus 8 is minus 2. So this is 6 minus 2. This is 6 minus 2. So what can you conclude about the product adjoint of A into B? Adjoint of A into B is not equal to 0. It is a matrix 6 minus 2. It is not equal to 0. So what can you conclude about the consistency of that system of equation? Here determinant A is 0. And now we have got adjoint of A into B is not equal to 0. So the second condition, right? The system is inconsistent and it has no solution. The system has no solution. All right. Now we are moving on to the next question. Prove that determinant of adj A is equal to determinant of A square, where A is a matrix of order 3 by 3. So A is a matrix of order 3 by 3. They have given that. You have to prove that determinant of at J is equal to determinant of A square. Okay. So how will you do that? You know a property, that is adjoint of A into A is equal to A into adj A is equal to determinant of A into I. Right? You know this one. Okay. So consider this part, adjoint of A into A is equal to determinant A into I. Consider this one. Okay, so determinant A into I means, and A is a 3 by 3 matrix. So which is the identity matrix that you have to consider here. It is also a 3 by 3 identity matrix, right? So which means this is equal to determinant A into matrix 1 0 0 0 1 0 0 0 1. This is a 3 by 3 identity matrix. And if you take this determinant A means it is a scalar value. It is a number, right? So how will you multiply a scalar to a matrix? You have to multiply the scalar number with each values, right? So here all these values are 0 except the diagonal elements are 1, right? The diagonal elements are only 1. So we can see that if you multiply this determinant A to the matrix, all the diagonal element will become determinant A, because determinant A into 1 is determinant A, right? So this matrix will become determinant A 0 0, then 0 determinant A 0, then 0 0 determinant A. Okay. So adjoint of A into A has become like this, right? And now I'm going to take the determinant on both sides. Okay. So this one is adjoint of A into A. Okay. So here itself, if I'm able to write, I'll write it here itself. So I'm considering the determinant of both sides. Okay. Determinant of adj A into A is equal to determinant of A 0 0 0 determinant A, that matrix determinant. Okay. So you are considering the determinant of that matrix. Okay, now you can split this, right? Adjoint of A into A. Determinant of AB is determinant A into determinant B, right? So this can be written as determinant of adj A into determinant of A equal to, we have got it as determinant A 0 0 0 determinant A 0 0 0 determinant A, right? And you know, if a scalar is multiplied in a determinant, when you take that scalar number to the outside, you have to consider the power of that matrix also. Here, order of that matrix, right? Order of A is equal to 3. So if I am taking this determinant A, since this determinant A is a scalar number, that is a scalar number. So if I am taking that outside from a determinant, what will happen here? You have to put the power of the you have to consider the order of the matrix, and that you have to put it as the power, right? That is, if determinant of k into b is given, then you can write this one as k raised n into determinant of b. And what is this n? N is nothing but the order of the matrix b. That's how you rewrite this. Okay, using this you have to rewrite this. Okay. So this will become determinant A cube into what will be remaining there. It is 1 0 0 0 1 0 and 0 0 1, right? Okay. So that is equal to determinant A cube into 1, because the determinant of an identity matrix, that is 1, right? So this has become determinant of at J into determinant A is equal to determinant A cube. And what can you say about determinant of adjoint A? That is equal to determinant of A cube by determinant A. Since both are a scalar number, we can subtract it, right? A raised m by A raised n is equal to A raised m minus n. So this is 1, this is 3. 3 minus 1, that is equal to 2, right? So this will become determinant A square. So we have concluded that, or we have proved that determinant of adjoint of A is nothing but determinant of A square. Alright. So moving on to our next question. Find adjoint A 4 A equal to matrix 2, 3, 1, 4. Matrix 2, 3, 1, 4. So this is our matrix. You have to find out the adjoint of A. How will you find out the adjoint? You have to consider the minors and cofactor. So how will you write the minor? M11. You have to remove the row. Sorry, this is a column. Column and row containing 2. So what is remaining? What is remaining? It is 4. And now what about M12? What about M12? You have to remove the row and column containing 3. Right. So what is remaining? 1. So the value is 1. And M21. M21 means you have to remove the second row and column containing it. Okay. 1 is the element and this is the row and this is the column containing it. So what is remaining? It is 3. And what is M22? M22 is 4 and M22 is 4. So this is the row and this is a column and this is the row containing it. So what is remaining? It is 2. So this is how you write the minus. And what about cofactor? Cofactors is equal to, cofactors is nothing but signed minor, right? Signed minor. And how will you put the sign here? This is 1 plus 1, 2. Even number. No need to change the sign, right? 1 plus 2 is 3. It is an odd number. You have to change the sign. So it will become minus 1. This is the value and you are putting a sign there. Okay, signed minor is known as a cofactor. And 2 plus 1 is 3. So it is an odd number. So you have to put a minus there. A22 means 2 plus 2 is 4. It is an even number. So keep it like that itself. All right. So this is our cofactor. And what is the relation between a cofactor matrix and an adjoint matrix? It is the transpose, right? So first you can write since this is of 2 marks, you can write it. You can explain it. For 1 mark and all, you can directly interchange the diagonal elements and put sign to the non-diagonal elements. Okay. So here the cofactor matrix. Cofactor matrix means it is 4, minus 1, minus 3, 2. Or you can directly write from this the adjoint A. Adjoint A is that you can write this one as column 4 minus 1 and then this one as the next column minus 2, 2. Okay, so this is our adjoint of A. Okay, so they have asked the adjoint, so this is our adjoint. All right, now we are moving on to the next question. Find the inverse of the matrices. Find the inverse. Find the inverse of the matrices. Find the inverse of the matrices. Matrix 2 minus 2, 4, 3. Okay, so you have to find out the inverse of the matrix. So the first condition that you have to check while finding the inverse of a matrix is that you have to check the determinant of that matrix. If the determinant is not equal to 0 or the matrix is a non-singular matrix. What do you mean by non-singular matrix? When the determinant is not equal to 0, then we can conclude that the inverse exists. Okay, then we can ensure that the inverse of that given matrix exists. So first you have to check the determinant, right? So let this matrix be A. Okay, so determinant of A is equal to, how will you find out? It is a 2 by 2 matrix, is cross multiply and then subtract, right? So 2 into 3 is 6, then minus 4 into minus 2. 4 into minus 2 is minus 8. So minus 8. So that is equal to 6 plus 8. 6 plus 8 is nothing but 14. So what is the determinant of the given matrix? It is 14. That is not equal to 0. So we can conclude that the inverse definitely exists. Inverse of the given matrix exists. And how will you find out inverse? Inverse of a matrix is equal to adjoint of that matrix divided by determinant of A. Adjoint of the matrix divided by determinant of A. And how will you write the adjoint of a 2 by 2 matrix? Adjoint of a 2 by 2 matrix is nothing but you have to interchange the diagonal element. So 2 will become 3 and 3 will become 2. Interchanging the diagonal element. And then you change the sign of the non-diagonal element. So minus 2 will become plus 2 and 4 plus 4 will become minus 4. So this is our adjoint. This is our adjoint of the matrix. And what about A inverse? So A inverse is equal to 1 by 14. That is our determinant. 1 by 14 into 3 to minus 4 2. 3 to minus 4 2. So this is the inverse of the given matrix. All right. Next, eighth question is examine the consistency. Examine the consistency of the system of equations 3x minus y minus 2x equal to 2, 2y minus z equal to minus 1, 3x minus 5y equal to 3. So these are the system of equation. You have to check the consistency of the given equations. Okay, for that you have to write the matrix A, right? So the matrix A is nothing but the coefficients of the unknowns, in an order, right? So these are the coefficients of the unknowns in the first equation. What are they? 3 minus 1 minus 2. Now consider the second equation. What is the coefficient of x there? 0. There is no value relating x, right? So the coefficient is 0. And what is the coefficient of y? It is 2. What is the coefficient of z? It is minus 1, right? Minus z means minus 1. And consider the third equation. What is the coefficient of x there? It is 3. What is the coefficient of y? It is minus 5. And is there any coefficient for z? There is no term related to z. So the coefficient is 0. So this is how you write the matrix A from a given set of equations, given system of linear equations. All right. And what about B? You can write B as the right side elements. 2 minus 1, 3. Okay. And what is X? X is the set of unknowns. Sorry, the matrix of unknown. So that is X, Y, Z. All right. And now what you have to do? First, you have to check about the determinant of the matrix. Okay. Determinant of the matrix is equal to, I'm going to expand it along the first row. Okay. So this will be 3 into minus 2 into 0, right? 2 into 0 is 0 minus 5 into minus 1, that is 5, right? Then you have to put a minus there, then this minus 1, right? Into, you have to delete the column and row containing minus 1. So it is 0 into 0 is 0 minus minus 1 into 3. Okay, so 0 minus minus 1 into 3 is minus 3. Then minus 2 into, next element is minus 2, right? The row, this is a column and this is a row containing minus 2. What is remaining? 0, 2, 3, minus 5. So 0 into minus 5 is 0. Minus 3 into 2 is minus 6, right? So this one, 0 into 5, 0, minus 3 into 2 is 6. Okay, so that is equal to 3 into minus 5 plus 1 into this is plus 3, right? Minus 2 into minus 6. 2 into minus 6. So the answer is minus 15 plus 3. Then this will become plus 12, right? So minus 15 plus 12 is equal to minus 3. That is minus 3 plus 3. Minus 3 plus 3 means it is equal to 0. It is equal to 0. So the determinant is equal to 0. So we can definitely say that it doesn't have a unique solution. Only if determinant A is non-zero, then we can say that the system is consistent and it has a unique solution. Okay, so here there are two chances. Here determinant A is equal to 0 means there are two chances. Either the system can be inconsistent or the system can be consistent with infinitely many solutions. Okay, so for that you have to consider the product adjoint of A into B also, right? So now I'm going to consider the product adjoint of A into B. Okay, adjoint of A into B, adjoint of A into B. Okay, for that we have to write adjoint of A. For that, first you have to find out adjoint of A, right? So for that, first M11. So I'll write the matrix here. Matrix A is equal to 3 minus 1 minus 2, 0, 2 minus 1, 3 minus 5, 0. So this was our matrix. All right. So M11 means first row and first column is deleted. So minus 2 into 0, 2 into 0 is 0. 0 minus 5 into minus 1 is 5. 0 minus 5 is minus 5. And what about M12? M12 is equal to, again, first, this is the second element, right? This is the second element. The row and column containing this is deleted. So sorry, this is a column and row containing is deleted. So the remaining is 0 into 0 is 0. Then minus 3 into minus 1 is minus 3. That is equal to 3. And what about M13? M13 is equal to, so this is the first row and this is the third column. So what is remaining here? The 0 into minus 5 is 0. Then minus 3 into 2 is 6. That is equal to minus 6. M21 means this is the second row and this is the first column. Right, M21 means second row and first column should be deleted. So what is remaining here? Minus 1, minus 2, minus 5, 0. Right, so minus 1 into 0 is 0. Then minus 5 into minus 2 is plus 10. Right, so 0 minus 5 into 2, that is 10. Okay, so that is minus 10. And what about M22? M22 is equal to, M22 means this one. This is the element, right? So 2, I'm sorry. Okay. So this is a column and this is a row containing, sorry, this is a row containing it. 2, 2 means. Okay. So 3 minus 2, 3, 0. You have to find out the determinant of that particular minor. So that is equal to 3 into 0 is 0 minus 2 into 3 is minus 6. That is equal to 6. Now, what about M23? M23 means the second row and third column. Okay, second row and third column. So 3 into minus 5 is minus 15 minus 3. Right, minus 15 plus 3. That is equal to minus 12. Now, what about M31? M31 is equal to, M31 is this element, right? This element. So this row and this column should be deleted. So what is remaining here? You have to find out this determinant. Minus 1 into minus 1 is 1 minus 2 into 2, that is equal to minus 4, that is equal to 5. Now what about M32? M32 is the third row and the second is deleted. So it is 3 into minus 1 is minus 3. Then 0 into minus 2 is minus 0. So that is equal to minus 3. Now what about M33? M33 is equal to the third row and third column is deleted. So this is the third row and third column, but remaining is this one. You have to find out the minor of this determinant of this particular minor. So 3 into 2 is 6. 6 minus 0 into minus 1 is 0. So 6 minus 0. Okay. So 6 minus 0, that is equal to 6. Okay. Now what you have to do? You have to find out the cofactors A12, A13. Directly you can find out the cofactor, but you should always remember to change the sign if you are directly finding the cofactor. Okay, actually cofactor and minors are same. What is the difference between cofactor and minor? That is, it is a signed minor. So we have to change the sign of certain elements. Okay. 21, A22, A23. Then we need A31, A32 and A33, right? So A11 is equal to minus 5 itself because 1 plus 1 is 2. It is an even number. Then 1, 2 is 3, which means you have to change. So it will become minus 3. 1, 3 is 4. So this is minus 6 itself. A21 means 2 plus 1 is 3. So you have to change the sign. So minus 10 will become plus 10. And 2, 2 means 2 plus 2 is even number. So you don't need to change the sign. So it is 6 itself. A23 means 2 plus 3 is 5. It is an odd number. So you have to change the sign. That is, it will become plus 12. And A31, 3 plus 1, 4. So you don't need to change the sign. It is 5. 3 plus 2 means it is 5, which is an odd number. So you have to change the sign. So minus 3 will become plus 3. A33 means 3 plus 3 is 6. It is an even number. So you don't need to change the sign. So it is 6 itself. All right. So what is adjoint of A? Adjoint of A, the matrix adjoint of A is equal to, write this down. Okay, minus 5, minus 3, minus 6. Now this one as a second column. 10, 6, 12. And this one will become the third column. That is 5, 3, 6. So this is the adjoint of the matrix A. It is minus 5, 10, 5, minus 3, 6, 3, minus 6, 12, 6. Now what you have to do? You have to find out adjoint of A into matrix B. Adjoint of A into matrix B. So that is equal to minus 5, 10, 5, right? Then minus 3, 6, 3, then minus 6, 12, 6 into 2 minus 1, 3. Okay. So here you can see here. So that is equal to minus 5 into 2 is minus 10. Then 10 into minus 1 is minus 10 plus 5 into 3 is 15. Then second row, minus 3 into 2 is minus 6. 6 into minus 1 is minus 6 plus 3 into 3 is 9. Then minus 6 into 2 is minus 12. Then 12 into minus 1 is minus 12. 6 into 3 is 18. So that is equal to minus 20 plus 15. That is equal to minus 5. Minus 12 plus 9. Right, minus 6. Minus 6 means minus 12. Minus 12 plus 9 is minus 3. And minus 12 is minus 24 plus 18. That is equal to minus 6. So this is our determinant. This is not equal to 0. So now we have obtained that determinant A is equal to 0 and adjoint of A into B is not equal to 0. So from this, what can you conclude? From this, you can conclude that the system is inconsistent. It is inconsistent and it has no solution. The system is inconsistent and it has no solution. All right. Now, moving on to our ninth question. Solve the system of equation 2x plus 5y equal to 1 and 3x plus 2y equal to 7 by matrix method. Okay. So equation directly itself, but here they have asked to find out the solution by the matrix method. So for that you have to change the system of equation into matrix form, right? For that first you have to write matrix A. What is matrix A? The coefficient of the unknowns, right? So the first you can see that 2 and 5 are the coefficient of unknowns, and in the second equation the coefficient of unknowns are 3 and 2. So this is our matrix A. And what about matrix B? Matrix B is equal to 1 and 7. 1 and 7. And what about matrix X? X is equal to the set of unknowns, that is, sorry, the matrix of unknowns, that is X and Y. Okay, now we can write this system of equation in the form of Ax equal to B. So from this you will get X is equal to A inverse into B. X is equal to, you solve the system of equation by X equal to A inverse into B. So for that first you have to find out the inverse of the matrix A. Inverse of the matrix A. Okay, so for that, for finding the inverse of a matrix, you have to first check the determinant of that matrix. If determinant A is not equal to 0, then the inverse exists. So first we are going to find out the determinant of A. Determinant of A is equal to cross multiply and then minus 2 into 2 is 4 minus 5 into 3 is 15. 4 minus 15, that is equal to minus 11, that is not equal to 0. So the determinant is not equal to 0. Inverse of that matrix exists. Now you have to find out the inverse. So for that you need to find out the adjoint, right? How will you find out inverse of a matrix? A inverse is equal to adjoint of A by determinant A. Determinant A we have already found out. Now you have to find out adjoint of A. Adjoint of A, that is a 2 by 2 matrix. So you have to interchange the diagonal element. Both are 2. Diagonal elements here you can see that the diagonal elements both are 2. So interchanging means that is 2 and 2 itself. Now what happens to the non-diagonal element? Non-diagonal elements means 5 and 3 are the non-diagonal element. You have to change the sign of the non-diagonal element. So plus 5 will become minus 5 and plus 3 will become minus 3. So this is the adjoint of the matrix. So this is the adjoint of the matrix, and A inverse is equal to 1 by minus 11 or minus 1 by 11 into 2 minus 5 minus 3 2. Okay, 2 minus 5 minus 3 2. So this is our inverse. This is the inverse of the matrix. Now we have to find out the system of unknowns. Sorry, the matrix of unknown, that is x equal to, we have to solve. So what is x? X is equal to A inverse into B. Now we have got A inverse, which means for finding x, you have to multiply A inverse with the matrix B, right? So that is equal to, we know x equal to A inverse into B. And what is this A inverse here? A inverse is equal to minus 1 by 11 into 2 minus 5 minus 3 2 into what is B here? B is equal to 1 7. First you do the matrix multiplication. Okay. Then you multiply it with minus 1 by 11. Okay. So on doing the matrix multiplication, we get the matrix as 2 into 1 is 2, minus 5 into 7 is minus 35, then minus 3 into 1 is minus 3, plus 2 into 7 is 14. So that is equal to minus 1 by 11 into 2 minus 35 is minus 33, and 14 minus 3 plus 14, that is equal to 11. Okay, that is equal to 11. So minus 33 by 11, right? This will become, if I take minus 1 by 11 to inside, this will become minus 33 by minus 11, and the second element will be 11 by minus 11, which means minus and minus gets cancelled. 33 by 11 is 3, and what is 11 by 11? That is 1, and here there is a minus, so it will become minus 1. So what are the unknowns? X is equal to 3 and y is equal to minus 1, and y is equal to minus 1. So we have solved the system of equation. What are they? X equal to 3 and y equal to minus 1. Okay, now the last question is, if A be any given square matrix, if A be any given square matrix of order n, then A into adjoint of A equal to adjoint of A into A equal to determinant A into I, where I is the identity matrix. Okay, it is the identity matrix of order n. You have to prove this property. A into at j is equal to at j into A equal to determinant A into I. So we can consider one part of this. That is, first you consider A into at j. So A is a A is a matrix of order n. So this can be generally represented as A11, A12, etc. A1n. Similarly, you can write the last one as N1, An2, etc. Ann, right? So this will be our matrix uh, uh, of order A. And what about adjoint of that matrix? Adjoint of that matrix will be A11. We'll write it to the downwards, right? So A12, etc. A1n. Similarly, here also you can see that it will be this will be An1, An2, etc. An. So this will be adjoint of A. And if you find the product A into Rj, what happens? A into Rj, what happens? That is, first you will multiply this row with this column, right? So which means A11 into cofactor A11, then A12 into cofactor A12, etc. A1n into cofactor A1n, which means the sum will be its determinant, right? That's how you find out the determinant of a matrix, right? So if you multiply the element with the cofactor of that same element, then and add it, then that is, if you find the sum, then you will get the determinant, right? So the first element will be determinant of matrix A. And what happens to the second element? Second element means you are multiplying this row with the second column of this adjoint. Second column means it will be A21, A22, etc., A2n, and it is a different cofactor, right? Which it is a cofactor of the second row, right? It is a cofactor of the second row. So if you multiply the cofactor of a different row with the with another row, then you know the sum is 0. Then the sum will be 0, right? So which means all the elements here will become 0. Okay, so if you multiply this row with any other column of this adjoint, then we know that the sum will be 0. Okay, similarly, what happens to the second row of the matrix A into Hj? What will happen? Second row, we know it will be A21, A22, etc., A2n, right? So, if you multiply this row with the first column, then you know it is different cofactor, right? These are the cofactor of these elements. So, we know the sum will be, if you multiply, and the sum will be 0, right? So, the first will be 0. And what happens to the second element? Second elements means the second row into second column means these are the cofactors of the second row itself. So we can say that it will be the determinant. Okay, so all other element will be 0. Okay, so here on doing like this, you will get a determinant like this. A into Hj will be like this. Okay, all other products will be 0. Okay, so and if I take this determinant A outside, I can take the determinant A outside. What will happen? All the diagonal elements will be 1, and the non-diagonal elements will be 0, and the non-diagonal elements will be 0. So which is the matrix like that? It is the identity matrix of order n. So that is equal to determinant A into I. Okay, that is equal to determinant A into I. So we have proved one part. Similarly, we can prove the other part also. That is adjoint of A into A is equal to determinant A into I. Okay. So these were the important questions that are in the session 2 mark. Okay. So we have discussed the important questions in the 2 mark session. I hope this session was useful to you all. So we'll have to discuss the 4 mark question and 5 mark questions of this chapter. So we'll be continuing 4 mark questions in the next session. Thank you.